Hi, I'm going to work out some problems from section 7.1, 7.2 of Lyell's e-text. This is about simplifying trigonometric expressions. First thing, you actually have to think about relating algebraic expressions. If you know how you would simplify an algebraic expression of this similar format, then you will have a good grip on simplifying those trig expressions as well. Notice for the first problem, this is given in factor form, which is 1 plus sine alpha times 1 plus sine of negative alpha. And you can do it in many different ways, but the first thing I would like you to take care of the negative sign. So if you remember that sine function, whether it's even or odd, that's what you need to decide. And since it is already known that sine function is odd, you can write it down, rewrite the statement in the second step, which is 1 plus sine alpha times 1 minus sine alpha. So once you have done this part, you think about writing down in algebraic form, which is just like my 1 plus a times 1 plus negative a. Since a negative a will turn out to be it's an odd function, so I could rewrite that statement like this, and it turns out to be 1 minus a square. This is by using the formula, right? You could have done FOIL method or other methods as well, but it's always a good idea for you to remember how to factorize, how to recognize the formula. If you don't remember those ones, I recommend that you revise chapter R summary. That one lists all of these ones. So all of these will be very important. I want you to remember each of those ones, and if you don't, make sure you get back to chapter R summary. So here a square minus b square can be written as a plus b times a minus b. A cubed plus b cubed is very important. If pay attention to those signs. When a cubed plus b cubed, the positive sign is maintained right here, and opposite sign is going with that ab term. If it is a cubed minus b cubed, you would notice that it will turn out to be a minus b, and this one will be plus. So all terms in the second factor will be all positive, but in the first factor it will be a minus b. So keep in mind about the sign changes. And a plus b whole square, that's one of the easy ones. It can be written as a square plus 2ab plus b square, and if it's negative, then only the middle term will change. If you want to expand the a plus b whole cubed, it can be written as a cubed plus 3a square b plus 3ab square plus b cubed. If you remember the Pascal triangle, you can easily rewrite those squared and cubed forms of binomial expressions. So that could be a handy tool if you do not remember how to write down. So something like Pascal triangle may be another helpful hint. Okay. Now, when I'm trying to simplify these factors, now notice I'm going to write it down just like my algebraic expression, just like this one. I'm going to write down 1 minus sine square alpha. Now the task is to match one of the trig identities, what you have already learned, Pythagorean identities. If you remember, we had worked on 3 different forms of Pythagorean identities: sine square alpha plus cosine square alpha equals 1, and that's the first form, the easiest one to remember. The other 2 can be written as when you divide the whole thing by sine square alpha, you get 1 plus this is cosine square alpha over sine square alpha, which becomes cotangent square alpha equals 1 over sine square alpha, which becomes cosecant square alpha. That is the second form of my Pythagorean identity. The third form will be, if you divide the same first form, you would divide it by cosine square alpha, so that time you are going to get that's turning out to be tan square alpha plus 1 equals secant square alpha. That's the third form. Okay, so all of these are very important. So once you come to a stage where you think you can apply Pythagorean identity, that's what you should try to utilize. So here I could substitute for 1, or I could have just simply think about what will be my term if I subtract from 1. If I take my sine square alpha on the other side, then what should I get? That's the thing you could replace. Or otherwise, simply you could have written down, instead of 1, I could have done something like this. As I said, in trigonometric expressions, you can approach the same problem in many different ways. So instead of 1, I rewrote this whole thing, and notice these two will be cancelled, and my final answer comes out to be cosine square alpha. Or you could have done just like from that statement, you could have figured that out by writing down 1 minus sine square alpha turns out to be cosine square alpha. I always recommend that you should use the identity and not just mentally do and substitute, because sometimes students can make mistakes with positive negative signs. So I recommend you always do this step by writing down the detailed substitution. Okay, this is the second problem I'm going to work out to simplify, and the directions will be just simplify. Okay, so basically you need to recognize again in algebraic form, if I had something like maybe 1 over a plus 1 minus 1 over a minus 1, figure that out what you would have done to simplify this algebraic expression. And when you have two different denominators, you always come up with the common denominator, right? So that's exactly what you would have done if it's in algebra. So here it comes out to be minus 1, and there's already a negative sign, so I'll be a little extra careful and put it within parentheses, and I'll put a plus 1. Okay, now if you simplify, notice the like terms will with opposite signs will be cancelled, so this one will cancel with that one, and here's negative 1 with another negative 1, it comes out to be negative 2, and in the denominator it comes out to be a square minus 1. Exact same idea. So I'm going to come up with the common denominator, cosine x plus 1 times cosine x minus 1. And here it comes out to be cosine x minus 1 minus, and put it within parentheses, the other denominator, whatever you had, you multiply by that one, right? So it comes out to be cosine square x minus 1, and in the numerator it comes out to be negative 2. Notice what happens this time. So cosine square x minus 1, it's a very common tendency for students to write down sine square x, but whether it's right or wrong, I'll verify that. So I'm going to utilize that first form of the Pythagorean identity, which is sine square x plus cosine square x equals 1. But I already have cosine square x on the left hand side, so I will subtract 1 from both sides, and I do end up having, and I'm just switching sides, right? So this one will go on the other side, and this one is coming to that side. So it comes out to be negative sine square x. It is not simply sine square x. So I I could, instead of writing it down, I will write down sine square x with the negative sign. By the way, the same exact step I could have done a little differently. I could have done cosine square x, and if I have any doubt, I will just replace 1 with my Pythagorean identity, and now I could have simplified. So these two would have gotten cancelled, and I would be left with negative sine square x. So either way, it works well. So now those two negatives will make it a positive quantity, and 2 over sine square x can be written as 2 cosecant square x.